Questions 11 through 20 on the 2002 Grade 8 AMC 8. A sequence of squares is made of identical square tiles. The edge of each square is one tile length longer than the edge of the previous square. The first three squares are shown. How many more tiles does the seventh square require than the sixth? So, if you see here, this has one square total, this has 4 squares total, and this has 9 squares total. Now let's label just how many are in one row. 1, 2, 3, like that. Do you see a relationship there? They're squares, right? So the fourth one, if you draw it really quickly, it'll be like this, correct? Where the individual rows have 4, but the total is 16, which is 4 squared. So that means that if you follow the same pattern, the sixth of these types of squares will basically have individual rows with 6 tiny little squares, but the total will be 6 squared, total number of squares in that shape. Okay? And similarly, the seventh one will have 7 squared in terms of the total number. And they want the difference. So 7 squared minus 6 squared is what they're looking for. So that's 49 minus 36, and that is 13. So 11, the answer is C. A board game spinner is divided into 3 regions labeled A, B, and C. The probability of the arrow stopping on region A is 1/3, and on region B is 1/2. The probability of the arrow stopping on region C is. So this is half, and this is 1/3, and they want you to figure out C. Well, the total probability is equal to 1, correct? Or 100%, whichever one you feel more comfortable with. They've already told you that A is 1/3 and B is 1/2. So to get C, you have to subtract from 1 because A plus B plus C is equal to 1. So A is 1/3, B is 1/2, and C is what we're trying to figure out. So C will be 1 minus 1/3 minus 1/2. Common denominator is 6. So that will be top and bottom by 2, top and bottom by 3, all over 6. So this is 1/6. So number 12, the answer is B. For his birthday, Bert gets a box that holds 125 jelly beans when filled to capacity. A few weeks later, Carrie gets a larger box full of jelly beans. Her box is twice as high, twice as wide, and twice as long as Bert's. Approximately how many jelly beans did Carrie get? So a box like that, the volume is length times width times height. And they're saying that the volume for Bert is 125 jelly beans. I'm assuming they've been packed in a way so that there's no empty space. Now they're saying you have Carrie. So that's Bert, you've got Carrie, and her volume involves a box that is twice as high, so 2L, and twice as wide, 2W, and twice as high, 2H. And they want you to figure out what is this in terms of a numerical value. So 2L times 2W times 2H, well, the 2's will multiply together to give an 8, and then you just have LWH, like that. Well, this one is LWH, and that's 125. So we can just substitute that into this. So I have 8 times LWH, which becomes 8 times 125, and 8 times 125 is 1,000. So Carrie will have approximately 1,000 jelly beans in her bigger box. Choice E for 13. A merchant offers a large group of items at 30% off. Later, the merchant takes 20% off these sale prices and claims that the final price of these items is 50% off the original price. The total discount is. Okay, so let's say, just make it easy for you. The items cost $100 each. All right? Now, the first scenario, you take 30% off. So you took off $30. If you take off $30 minus 30, you get items at $70. Correct? Now, at this point, you've got items at $70. And we want to take off 20%, not $20, 20%. What is 20% of 70? Well, you do it a little bit on the side if you're not sure. 0.2 times 70 is how you get 20%, and that's 14. So you're going to subtract $14, and that would leave a price of $56. Okay? That is where we arrived from 100. So what is the total discount? So please be careful. Please don't choose choice D. The discount, when you went from 100 to 56, you discounted how much? $44, right? 100 minus 56. This $44 is how much was the discount. So the answer for number 14 is B, 44%. Because I chose 100, and 44 divided by 100 is 44%. Which of the following polygons has the largest area? All right. So let's blow this up a bit. And that's about as big as I can make it. All right. Now let's just quickly look individually at each of these. We can just label them 1 as in terms of the length of those sides. And one thing I think you'll quickly notice is they're all either squares or triangles. Well, we'll see. So if we label it 1, 1, each of these squares will have a volume of 1, or area of 1. Sorry, not volume. Area. So 1, 1, 1, 1, and then the triangles, well, 1/2 base times height, so 1/2 times base, which is 1, times height, which is 1, and therefore the triangles will each have an area of 1/2. Like that, if I can squeeze it in. So if we do that, we can quickly calculate the area of all of these. So the first one, 1, 2, 3, 4, plus 1/2 and 1/2, so that area is 5. Okay? Second one, let's see how many we have. We've got 1, 1, 1, 1, and we've got 2 of these halves. So that would be 1, 2, 3, 4, 5. So that's also 5. All right, this one here. Oh, this is not a square or a triangle, but it shouldn't be difficult to figure out the area. First, let's just do these ones. 1, 1/2 and 1/2. So that's 1, 2, and 3. And then we have to add to it this one. This is a parallelogram. So if we say this is the height and the base is from there to there, that's 1 and the base is 2. So the area is 1 times 2. So that becomes 3 plus 2, which is 5. All right, so far there's a tie. Next one over, we've got 1, 1, 1, 1/2, 1/2, and 1/2. So that's what? 4 and 1/2, so 4.5. And then finally, let's see here. First, let's break it up. We've got 1, 2, 3, 4, 5 and 1/2. All right, great. So you see how I did that? If you do that, you'll see that the largest one is, for number 15, is E. This one right here. This shape. Right isosceles triangles are constructed on the sides of a 3, 4, 5 right triangle as shown. A capital letter represents the area of each triangle. Which one of the following is true? All right, so a little bit of work here. They're isosceles, right? So if that's 3, then that means that that is 3 also. So label that there, 3. Similarly, this is isosceles, so both of those sides are 4. 4 and 4. And similarly, this is isosceles like that. So both of those sides are 5. So we can quickly figure out the area with just 1/2 base times height. X is 1/2 base times height. 3 times 3, like that. So that is 9 over 2, sorry, which is 4.5. Okay. Very similarly, y is going to be 1/2 base times height, 4 times 4, which is 16 over 2, which is 8. So y is 8. Z is 1/2 base times height. So that looks like 25 over 2, which is 12.5. And finally, W is 1/2 base times height. Base is 4, right here. Height is 3, right there. So we've got 12 over 2, which is 6. And now we just have to figure out which one of these equations holds true. X plus z, let's do this here. X plus z plus y plus w. X plus z is 4.5 plus 12.5, and that is equal to 17. And w plus y is 6 plus 8, which is 14. So that one is not true. All right. B is next, okay? W plus x. What do we have here? W 6 and 4.5, which is 10.5. And z, just z by itself, is 6. So 10.5 is not equal to 6, so that's wrong. C, 3x plus 4y. 3x plus 4y, well, 3 times x looks like 13.5. 4y is 32, so that is 45.5. And then 5z is 5 times 12.5, which is 62.5. And those are not equal. All right, they're really making us work here. All right, let's keep going here. D. X plus w, 4.5 plus 6 is 10.5. And we got half of y plus z. Y is 8, z is 12.5, so 20.5, half of that. 20.5 divided by 2 is 10.25. Ooh, we came close there, but that's not the one either. All right, so E has to be correct, unless I made some boo-boo, which I hope I didn't. So x plus y is z. All right, x is 4.5. Y is 8. That is 12.5. Z is 12.5. Yay. All right, so E is the correct answer to this question. That was question number 16. In a mathematics contest with 10 problems, a student gains 5 points for a correct answer and loses 2 points for an incorrect answer. If Olivia answered every problem and her score was 29, how many correct answers did she have? So correct I'll represent with C, and incorrect I'll represent with I. And correct plus incorrect has to equal 10 because there's 10 problems and she answered every problem. She didn't leave any problem blank. And then if you look at the point system, for every correct you get 5 points, and then for every incorrect you lose 2. So that is the point system equation, and that for her is 29. So those are our two equations. We can solve. We can first isolate for one of these. I'll isolate for I, so that'll be 10 minus C, and then substitute that into equation number 2. So 5C minus 2I, 10 minus C, is equal to 29. So 5C is minus 20 plus 2C is 29, and therefore 7C is equal to 49, and C is equal to 7. So she answered 7 questions correct, and that would be for number 17, choice C. Gage skated 1 hour and 15 minutes each day for 5 days, and 1 hour and 30 minutes each day for 3 days. How long would he have to skate the 9th day in order to average 85 minutes of skating each day for the entire time? Okay, so 1 hour and 15 minutes, 1 hour and 30 minutes. So let's convert this all to minutes, since probably it's a little bit easier. So 1 hour and 15 minutes is 75 minutes, and he did that each day for the first 5 days. So 75, 75, like that. And then the next 3 days, he skated for 1 hour and 30 minutes, so that's 90, 90, and 90. And then on the 9th day, so this day, that's what we have to figure out, how long. So I'll call that X. And this is the average of 9 days, so all of this is going to be over 9, like that. And they want this average to be 85. Okay, so let's do the math here. Cross multiply 9 times 85, so we get 765, and then add all this up. Looks like 375 plus 270 plus X, so we got X is going to be 765 minus 375 minus 270, which is 120 minutes. And 120 minutes, so let's see which of the answer choices. That's 2 hours, correct? So 18 is E. How many whole numbers between 99 and 999 contain exactly 1 zero? All right, so we've got a range from 99 all the way till 999. That's our range. So in terms of the actual numbers, it's 100 to 998, because they're between, right? They don't include 99 and 999. Not that that really makes a difference, but it helps us a little bit, because we will get this 100 in there. Okay, so it obviously will only include 3-digit numbers, because all the numbers from 100 to 998 inclusive are 3-digit numbers. So 3-digit numbers, it wants exactly 1 zero. So where is the 0 going to be? Is the 0 going to be here or here or here? Well, let's look at the first scenario. Let's say the 0 is there. Well, if the 0 is there, that's not going to work, because this no longer becomes a 3-digit number. If you put any other numbers in here, it's a 2-digit number. So the 0 can't be there. The 0 can only be here, or the 0 can only be here, the last position. These are our only 2 scenarios. So we only have 1 0 to place, exactly 1 0. So the other 2 cannot be zeros. This and this cannot be zeros, but they can be any other number. So how many choices do we have for the first position? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 digits that we can possibly put. So we have 9 possible combinations. And then the 0 is fixed, so that's just 1 possible combination. And then what about the last digit? How many possible? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Same thing, 9 possible combinations. So get the total. To get the total, you multiply them. 9 times 1 times 9, which is 81. All right? That's how you figure out these types of questions. And there will be many of them, and a lot more complicated as the years go by on math contests. And now let's look at the second scenario. The first digit, what possible choices are there? So very similarly, any digit from 1 to 9 inclusive. So 9 possible choices. Second digit, any digit from 1 to 9 inclusive. And the last one is fixed as a 0. So there's only 1 possible choice there, which is 0. So this also gives you 81 choices. All right? So you have to now add these up. 81 plus 81. And this gives you 162. So number 19, the answer is D. The area of XYZ is 8 square inches. Points A and B are midpoints of congruent segments XY and XZ. Altitude XC bisects YZ. The area in square inches of the shaded region is. All right, let's start by doing some labeling here. Let's see, from X down to C, I'll call it X and X like that. Or actually, you know what, let's not use X's, so we already have an X here. Let's use A and B. Oh, we got A and B. All right, I should have probably chosen some letters ahead of time. It doesn't really matter. Y, W and V. W and W. And the reason is because XC, they tell you, is the altitude, right? It's from there to there. And A is the midpoint. A is the midpoint of XY. And B is the midpoint of XZ, like that, correct? So if you have this line AB, it will cut XC in half. That's basically how it works. So that means that the distance from X down to there is, if it's W, the distance from the midpoint to C will also be W. Okay, that's why those are the same. And very similarly, if you draw a line from, let's say, A down to the bottom like that, and B down to the bottom like that, those will also be W in terms of their length, like that. All right? And then we also need to label the bottoms here, these ones. And in a very similar way, those are all equal. They tell you that XC bisects YZ. XC bisects YZ. So that means that this is equal to that. That's entirely from the question stem. But since A is a midpoint of XY, if you drop a perpendicular from A down to YC, that will bisect YC. So that will be the same as that. So all four of these are equal. All right? So we can label them any letter you want. You can use, let's say, V. Okay. So let's go ahead with what they tell you in terms of the area of the full triangle. The full triangle XYZ is 8 in terms of its area. And how do you figure out the area? It's 1/2 base times height, like that. So 8 is equal to 1/2 base. The base is all the way across, which I have labeled as 4V. And the height is from top to bottom, which I have labeled as 2W. So do the math here, and you get 8 is equal to 8 over 2 VW. And VW, therefore, that's 4, so 8 divided by 4 is 2. So there you go. Now we have to figure out the area of the shaded region. So the area of the shaded region, AS, first one is just a rectangle, like that. So that's just length times width, so that would be W times V. And then add to that this triangle, which is 1/2 base times height. So 1/2 base times height. And instead of base and height, instead of putting in more letters, let me just put in what the base and height are. The base is V and the height is W. So this looks like 1 VW plus 1/2 VW, so that's 3 over 2 VW. And we know from our first calculation that VW is equal to 2. And therefore this becomes 3. So the area of the shaded region is 3, so 20, the answer is D.